Hello, everyone. I'm from F5. I don't know if you know us as a company already, but we are doing applications and application security more than 27 years now. And today I want to use this opportunity to tell you something about API security and why is it so important and what's the difference compared to application security itself. In relation to this topic for this conference, cyber evolution, I just want to give an example why it is difficult, or maybe it's different, to have the right approach for API security. The application world itself has changed, has evolved over the last, I think it's almost 10 years ago. And what I mean by that is that I think it was 2013 where everyone started to think about move applications or move workloads into the cloud, into one cloud, for example. That's at least what our customers are starting to think about in 2013. Still, just move an application or a workload to one cloud is easy. Sounds like easy, but it's one way, one access. It's easy to protect, of course, or maybe can be easy to protect. But in reality, things never happened as expected. And today, and you should know this already, we don't have this one cloud where all the applications are moved or where the workloads are moved. It's there's a name for it. It's called multi-cloud, because our customers, or at least almost every customers, have not just one cloud, not just one destination where applications are located and where workloads are deployed. In reality, we have AWS, all the public cloud vendors. We have private cloud vendor. Each customer, or every customer, should have its own private cloud environment, for example. We still have the data centers where all the applications still exist, or even maybe exist for the next 10 years. And we have new things like Edge, for example, where the application is close to the end customer, or can be placed close to the customer. And as you can see, it's not just one destination, it's not just one access to the application itself, because all those different locations needs to be connected. We have a connection, we have a communication, east-west or north-south, in all directions, and this makes it at least a bit more complex and a bit more difficult to deploy or to place the right security functions in place. So with this new world, with this distributed world, we have still our applications which can be located still in the existing data center, or just move to one of the public cloud environments. That's easy, but still, it's not the end of our journey, because as everyone knows, we already have some kind of container or virtualized environments. That means we have even the application itself has changed or evolved over time. So now we have no longer this big application which is placed in one location. We have small parts of the application, also called as microservice or microservices, or small part of the application itself. And there is communication for all of those, between all of those. And to make it a bit more complex, you can even deploy containers in different locations. And there's one thing, and this is the topic for today, which make this enables customers to have such distributed environment. And this is a new way, a new protocol sometimes to communicate, to exchange data between all those microservices and application parts in different locations. This is called Application Programming Interface, or in short, it's an API, and those APIs are used to exchange data. And we just heard in the example before that APIs can be used or misused to get access to data which shouldn't be accessible from outside to everyone, for example. But the important thing is, and this is something you can see by this picture, it is a distributed environment. It's not easy to protect all those microservices, all those containers or locations, because if you are using the specific solutions from each, let's say, public cloud, for example, they are different. It's not easy to understand or to provide consistent security policies, especially for API security in all those different environments. But still, applications, microservices, APIs should be accessible for everyone, at least for the clients, for the internal, for the employees, and of course for the business partners as well. So you need to have multiple access options for those microservices, and sometimes even you have communications, or most times you have communications where the microservice communicates to a different microservice without any client interaction, for example. But this is something not just you or your clients or your customers are aware of, but also the bad guys in the world. And they have now at least some more places, some more angles where they can try to attack or gain access to applications. This is the one thing why API security, especially API security, I mean, I know there is more security needed to protect your applications in all those locations, but still, the API is available and needs to be protected. So let's have a deeper look into APIs. So we have just heard about that APIs are accessible, and there was a picture where you could just use this source code for this API call and can just manipulate by changing a number or whatever and get access to data you shouldn't have to. Why is this? APIs are available by design. They should be accessible by any client, by business partner. I just showed you in the example before. And of course, to understand how to use those APIs, there needs to be documented, which makes it easier for an attacker to understand where is maybe a possible attack vector, where can I start to start my search, or where can I try to get access to data which shouldn't be available for me and if I use this application in the right way. And of course, and again, just the example before, APIs, because of the design and then the idea behind, they can provide access to sensitive data as well. That's the design, that's the idea for using APIs and exchanging data to provide such a portal you could see in the presentation before. So this presentation was built, I think maybe it was designed by different microservices and all together were displayed in one portal, for example. But the communication between is used or is done by using APIs. All right, today we have around 200 million APIs already. I just showed you the picture where you could see how distributed the application world is today. And right now we have already lots of places where you need to apply or needs to implement some kind of application security or API security functions to protect your application at the right level. In the next couple of years, we expect this to grow up to almost 2 billion APIs globally, and I think it's clear to understand that this makes this situation even more challenging for the security guys to provide the right API protection. Oh, I'm doing in time? Okay. This is just one big challenge. The huge number of APIs makes it difficult to keep the pace or keep the right security solution in place, especially for APIs. Is any application security guy in the room? Anyone aware of how to implement application security policies for an application? It's difficult because everything is automated, especially in an API world. And that means usually customers have more developers than security guys which are responsible to protect your application. The pipe, the continuous integration, continuous development pipe is built for speed, not for security. It is hard for a security guy to keep pace, to provide always the right security solution to protect your application. And that means API security today needs some functions to discover changes in the application, in the API. It needs some kind of inventory to see, to display what is in my API, what is in use, what is maybe not in use but still present, for example. Any rogue APIs, is there something new, something different, something the security guy is maybe not aware of. API security needs to provide such data to help protect it at the right level, for example. Just a quick look what kind of APIs are available. It just depends on the access level, if it is designed for internal use or for external use. I just want to go a bit more deeper because it's not that easy to just say it's an application, just provide or apply an application or WAF policy, and that's easy. It is not, because API security requires a specific knowledge or a solution which is able to understand the protocol which is in use, for example. Just to give you one example here, everyone knows RESTful APIs, maybe? RESTful APIs is a common API which is in use since years now. It's a kind of easy because it's a structured API. There is a clear structure of available endpoints, how you can access the endpoint, what kind of data you can get from them. Everything is clear, and you have to use a specific method to get your data from this API and so on. It is different if you are using, for example, GraphQL. There is not just one endpoint, not a list of defined endpoints. It's just one endpoint. And you can use a query language to craft and to build your specific query to get your data. It's a different approach, and it is difficult for a security guy to protect those applications because there is no clear structure. You have to wait what the client is asking for, and then you have to pass and to validate if this request is a good or a bad one. And this goes on, and it really depends on the solution which is in place. And that means API security, or to protect an application, and these days today, you need to have a specific approach, not just application security. You need to have something specific for APIs, which is usually called API security. What is API security? In most cases, it overlaps with application security. But to simplify it, application security is used to protect your application against vulnerabilities like Log4j, for example. Everyone should be aware of this. And any attempts to bypass the application logic to get data, get access to data which shouldn't be available. API security is more focusing on the communication between different microservices. It's really going down to the protocol and not just the application logic. And just one thing which I think is really important. Without API security in these days, there is no 100% or no way to protect your application at the right level, because you are missing a very important part of it. So just move on in regard of time. API security needs to be automated, of course. I just explained the example with the pipe. So we need to have a solution which can be automated, which can be integrated in existing automation tool chains, for example. But still, it needs to provide some data about what is happening. Is it still the case? Is it still my API is still looking like it should be because there is no change, no new endpoint or whatever? If not, just explain me, just show me what happens. If there anything new, anything unprotected or unusual or misbehavior from the clients, from the user, which could be or could point to a malicious activity, should be available by the API security. And of course, to protect it, not just say there is something wrong, but provide also a way to protect it in real time. That's very important here. Just have a deeper look to it. Enforce what is known. So if you know I have a RESTful API, I know my endpoints, I know my method, I know my parameters, it's kind of easy to protect as long as I could understand the protocol which is used, XML or whatever, JSON. On the other hand, we should provide details or insights about any new, any rogue, any unmaintained API, for example. And of course, we should have a deeper look into the request itself, but also in the response, what is delivered to the client. So it's a full approach, and the API security solution should be able to provide details and to protect your APIs in that way. There's also one challenge, which is, I just mentioned, it is easy for a security guy to provide a security policy for an application, especially if the application guys are not informing those and the guys and say, look, we have a new version, please adjust your WAF policy, your application security policy. Same is valid for API security. It can happen that, in the first picture, API is running in a certain version, API security is configured, everything is fine. They just deploy a new version of the API without informing the security guys, which is, depending on the application, can happen quite often. Some applications have thousands of changes per day, so it's even harder to provide your application security policy at the same speed. But the API security solution should be able to detect there is something new, something different, and provide at least some details so that the security guys can adjust their security policy either automatically or by reviewing it together with the application guys, for example. But just make them aware that something has changed without looking into logs 3 days or weeks after, just in real time, as soon as this difference occurs. And of course, this is a never-ending, or it's a loop. So because as soon as you have adjusted your security enforcement, they will deploy a new version, and this process has to start again. So what we as a 5 can offer for API security? I still have 3 minutes. I make it more quick. So we have exactly this API discovery functionality and developed to provide those insights and to make it easy for our customers to understand what kind of APIs are in use and what are the changes for those APIs. How are they used? We also have a bot defense solution in place, which is a bit misleading because it's not just blocking bots. It is also identifying unwanted automation. So any kind of browser automation or Selenium browser, whatever could be used, can be detected and can be blocked if it is not useful or not wanted in the application itself. And of course, some details about the usage of the API. Is it still my users which are accessing the API or not? Is there something malicious, a spike in the traffic, unusual traffic pattern, whatever could happen should be visible in the solution itself. And just to give you an idea how it looks like, so this is something you can just enable API security, define the ingress, also where the clients can connect your application, and define the egress, where your application is located. Doesn't matter in which location. Could be public cloud, private data center, co-location, doesn't matter for us. We can securely connect all those locations without creating new effort for you by connecting all those locations. And with this simplified access, we have a one access point where you can deploy security functionalities, and of course we can provide insights on data, informations about what kind of APIs are in use. And with those overview, we would easily see if there is everything fine or is maybe some just one new endpoint in your API, and you can do something about it. Same is for the behavior itself. How are they accessed? I just explained before. Is it still this as it is expected, or is it something unusual and you need to have a deeper look into it, for example? Same is for authentication, because it is, I just skipped maybe the point before, but zero trust or the authorization, provide access with least privileges is very important for providing API security as well. 30 seconds? Okay. So this is something maybe you want to know if there is some attempt to access your API without authentication. And same is for getting insights about what kind of data are exchanged, for example. And one last step, I have still 20 seconds. You can easily import API definitions to make it easy to configure all your APIs. But keep in mind, if you don't have those, we can just learn what happens on your API and provide you insights about this. And with this, it's my last slide, so almost in time. Get ready for lunch. We have a solution in place which is perfectly designed for providing API security and connect all those distributed locations and make it easy and give you a chance to provide consistent API security policies and, of course, application security policies to protect your APIs. With that, I'm done. Thank you.